Okay, I think I will discuss this problem. Okay, we begin with number 87. Okay, so as you can see here, the problem, we want to do the okay. Basically, we want to do the L'Hopital rule, right, with this problem. But the problem is the problem is not yet is not yet infraction from infraction. So there is no numerator and denominator. So first of all, we want to transform this problem into fraction. How to do that? A lot of ways, but I think one of the easier ways is to substitute x with y, such as y equals to 1 over x. Okay, so now we have our problem become limit of y approaching 0 of 1 over y minus 1 over y square ln 1 plus 1 over y over 1 over y. And from this, quite easy, right? Y to 0. This one, I want to make denominator become y square over y square. So 1 over y become y over y square minus uh, ln of what? This one is y plus 1, right? Okay, so far so good, right? It's just a normal fraction manipulation, nothing weird here. Okay, so from here we do L'Hopital, of course. Where is my pointer? Yes. Okay, let's say here with L'Hopital. I'm not sure how to pronounce, but you know what I mean. Of limit y approaching 0. So the numerator differentiation of to the y is 1 minus 1 over y plus 1. You have learned this one, right? The derivative of ln is 1 over x. Okay, so no problem here. Over to y. Hmm. Well, I think it's convenient to do once again because we can do L'Hopital until whatever we feel convenient, right? 0 plus 1 over y plus 1 square over 2. So we get what? Half, half. We get half right here. Okay, so far, any question? Oh, sorry, I forget to mention why I do L'Hopital twice, because as you can see here in this, when we just doing only once here, uh, this this is still in the form of 0 over 0, right? 1 minus 1 is 0, 0 over 0. So we do L'Hopital again. That's the reason why we do L'Hopital. I think the hard part of this problem is to think about the idea of substitute x to the y equal 1 over x. The rest is trivial. But if you don't do this, I think it's quite difficult, right, to solve this problem. Okay, so far so good. Any question? No, right? No. If not, okay, we do the other problem. This one. I think this one should be. I don't know. Maybe easier. I'm not sure. Okay, this one is equal to limit x approaching 0, sinus 2x, x to the x cubic plus bx plus limit x to 0 a. As before, I want to make it into fraction equal to 0. So I think we can do L'Hopital now. So we have x to the approaching 0. The numerator become 2 cos 2x plus uh, b over 3x squared plus a. This one is just a equal to 0. Okay. Now the problem is it is not uh, so we need to make it into indeterminate problem, right? Actually, it doesn't need L'Hopital, but hey, do we need L'Hopital? I'm not sure.
something over zero.
Yeah.
In order to solve it, the numerator should
Zero
zero
to.
or something.
Yes, yes, yes,
So
yes.
we can like import the numerator to
Yes, 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 yes. Yes, that's the idea. So I think yes. So it should be uh minus a basically, right? Do we want to do?
Professor.
Yes.
Have the tends to think for x takes to put x plus x and
Oh yes, yes, yes. You can.
x
Uh,
becomes x
yes.
plus one.
Yeah, 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 yeah. You can do that, but
After all the denominator is x squared and thus 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 sorry.
mm, yes, but I am not sure it's. Do you think that's make it simpler?
Um, I get the answer from that, but I'm not sure it's true.
Oh, yeah, yeah, yeah. I understand what you mean. So we turn cos 2x into cos square x minus
So
no two sine x cos x.
all
Uh,
the denominator is x squared
uh,
and then cos zero is one. So we got over x squared plus a plus zero x squared.
I think it can work, but it's not. I guess it's not simpler, but uh, sorry, what? Oh, I'm not sure. Wait, is it okay? It's better. Or it's too thin. And differentiate. Mm, yeah, does it solve the problem? Because the idea is, I think this form is the easiest to solve. I'm not sure. So, because here, if we substitute to uh, this one is become two plus b, right? The,
Yes, because
two plus b.
the b is minus.
Yeah, yeah. So I think this one is the easier to solve because we need to ensure that where's my pointer? Where? Sorry. Oof, oof. Oof. Okay. So we must ensure that 2 cos 2x plus b equals 0. So it's become indeterminate form, right?
I just changed the symbol.
No problem. But I think let us see the.
Oh, yes, it's not.
Yes, yes.
Okay.
So the first one become because we substitute x with 0, so 2 plus b equals 0. So b equals minus 2. And so here a now what is a? Your a is 0.
Yes, because AX product equals so I don't know.
Okay, how to find a, I guess, is we need to do L'Hopital again. So we do L'Hopital once again. So what we have is limit x to the 0, and now become of minus 4 cos 2 x is sine 2x, right? I think so far so good. Over 6x. It's still 0 over 0, right? So we do L'Hopital again. What we get is limit x approaching to 0 is minus 8 cos 2x over 6, right? Do I make mistakes so far?
Oh, but there's no A or B there.
There is, because this one must be same as minus a, right? From this part. Do you get my point?
But this is B is minus 2, but B is
Yes.
the form that you use the lower count is not indeterminate. It's going to be oh, okay, I get it.
Get it? What? A over minus. Yes. So a is 4 over 3. Because this is minus and minus 2. So from here we get a equals to 4 over 3. You get why a is not 0 here, because the first part is not 0 too. If yeah. So if a is 0, then the equation become 4 over 3. Become become minus 4 over 3. So not become 0. That's why a should be 4 over 3. Is there any question from the class? No, right? Still confused? No? Okay. Yeah, I understand why you get the B, but you think, oh, when the B, we find B and the A's just disappear. No, not that easy. Yes, sure. You come. Okay. Anything clear? Wow. Do you guys can in the internet can see something or not? I will window and sorry. It's become disappear and la 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 disappear. Sorry. Hope we have a lot of things before the time is up because of office. So okay, next I want to try to solve this problem because hopefully we still have time. I just want to show you some trick, I guess, to how we can solve this problem. So this one equal to, well, I divided by x over 1 over x, so we have limit x to infinity, x plus 2 over x over 1 over x over x plus 3 over x 1 over x minus 1 minus 1. Do I need to do this? I think so, but so it's hard to solve this problem, right? I mean, without without changing into something that we can derive. So we do some. I think you have been familiar to this trick, right? What I want to do is to make a exponent of learn this thing, do 1 over x minus 1 over a ln x plus 3 over x power of 1 over x. Do you familiar with this trick? Familiar, right? From this form yeah. So this one equal to limit x to the infinity a of 1 over x then x plus 2 over x minus 1 over a over x then x plus 3 over x minus 1. Okay, we do L'Hopital. And we have limit x to the infinity. This one would be, I think, the derivative square minus plus x over x plus 2 1 over x. I think you can do the rest, but because our time is up, but you follow this kind of line and you will find the solution. Okay. I think that's all for today. Do you have any question? No? If not, then I think that's all for today. Thank you very much. And if you have some question, you can ask me in the Moodle or send me email. Thank you.